Hello, everybody. Welcome, and thank you very much for joining us today. My name is Alec McCutcheon. I'm a director of Unicom, and we're absolutely delighted to be hosting today's webinar. I'm really excited. There's been a lot of interest in this subject. I think it's very timely and really topical at the moment. We're going to be talking about a new approach to audio and visual testing. Sorry, audio and video testing. As I'm sure everybody's aware, the way rich media content has changed dramatically over the last 2 years. Audio communications, streaming applications have really skyrocketed and exploded, and it's proven that they're here to stay. Today, we've got two fantastic presenters, Jonathan Lips, who's Director of Learning and Education Programs, and Gaurav Mathur, who's Chief Operating Officer of Headspin. And they're going to be sharing with you and talking about some novel approaches to audio and visual testing that address the challenges we're facing at the moment and offer visibility for organizations that need to succeed in today's experience economy. So I'm now going to hand over to Gaurav and Jonathan, and there will be opportunity for questions at the end. So if you have any questions, please type them into the chat box on your screen, and we'll try and answer as many questions at the end as we can. So Gaurav and Jonathan, over to you. Thank you.
Well, Alex, thank you very much, and good morning, good afternoon, good evening, everybody. It's a real pleasure to be here, and thanks for taking the time out of your busy schedule to join us. I'm going to start by showing you a small video. So hopefully this video gives you a trailer of what we're going to talk to you about today. To give you a brief introduction, Headspin was formed in 2015 in Palo Alto, Silicon Valley. I'm Gaurav Mathur, the Chief Operating Officer, and joining me is Jonathan Lips, who's the Director for Education and Learning, also the co-founder of Appian. Our mission is to help clients perfect their digital experiences. We're backed by blue chip investors, and we've been very fortunate that around the world, we have worked with a number of clients, especially in the digital natives, in telcos, in financial services, in media and entertainment, helping them perfect the quality of digital experiences they provide to their customers who are consuming these services or products in different parts of the world and through different devices and different operating systems. as you saw in the video, I mean, first of all, the consumption of audio and video is, as we all know, is growing, whether it's the OTT media platforms or the voice assistants or the chatbots and the conversational AIs. So as the volume of this delivery and also consumption of audio and video keeps on increasing around the world, it's absolutely essential to ensure that the experience, the digital experiences that the end customers are getting are flawless. And the common challenge that is faced is that quite often non-functional performance testing is not part of the development phase and happens quite late in the release cycle, or quite often the issues are found post-production. And then there's a lack of a continuous feedback loop on how the delivery of these products and services are impacting the consumers. So the providers of media and entertainment, whether you're a media entertainment company or whether you are in any industry, but you have video or audio content to show, it becomes imperative for them to capture the quality of media, the main KPIs, especially of DRM-protected content, to access the perceptual video quality without references to video or subjective user-submitted measures. And also, given the pace and the volume and the quality required, it becomes highly important to automate the audio and video testing across the different devices. Now, we all know we consume video and audio through various devices, whether it's a tablet, whether it's your mobile phone, whether it's your smart TVs or smart speakers, or indeed, if you're on the go, the way you consume on your automotive infotainment systems. Now, beyond these three main challenges, all companies have to realize that delivering the content with numerous variables is absolutely essential to give them the great quality media experience that they want. And the whole distribution is in a very vastly distributed and complex ecosystem. In the search to create high quality video experiences, there's so much to consider from all ends of the ecosystem, whether it's the delivery factors like the network traffic, the carriers, the third-party APIs, the 5G, the cloud providers, the consumption factors, how the users are consuming different devices. And hence, this is placing the need to provide a solution that can meet the requirements of any client that is providing top quality audio and video content to the end users. So where do we come in? So what we have done is we have built patent pending AV platform technology that enables true black box testing by capturing the real user experience on real media devices, including actual screen and audio output. As such, it can be used to test a variety of use cases, including OTT media, live streaming, accessibility, voice activation, video calling, communication apps, camera apps, voice assistants, and also test DRM-protected content. And we do it by having a centralized device lab for distributed test teams that enables enables accessibility remotely, and it's compatible with automation framework. So how it actually works, that Jonathan will be taking to you in greater detail. But what we have also built is a solution that can help you really capture what is the real-time experience of your end consumer who's consuming this audio and visual content, either sitting in the comfort of their living room or in their bedroom or on the go. So I will now request Jonathan to show you in greater detail how do we make this solution work, and also share with you an exciting case study. Actually, before I hand over to Jonathan, is a work that we have been doing with a global media house. Now, as mentioned earlier, similar to the challenges faced by the industry, they were challenged to evaluate how well their content is streaming on the recently launched OTT devices across various platforms. And it was important to ensure that the functionality and performance of apps across the key markets in the US and Europe were met. And of course, in doing that, continuously improve the existing QA processes and automate it further. So we have provided, and we've been working with them for the last 1 year. We've provided them a set of global devices to test the video player functionality. We've given them granular AI insights and also uh, enabled them to test certain KPIs, key KPIs, which Jonathan will explain in more detail around blurriness, video quality, blockiness of DRM content, and also with our patented reference-free video MOS. Now, the impact of all this is that it has given our client the ability to really evaluate the content that they are displaying on smart TVs. And also on different streaming devices, be it Fire Stick, be it Roku TV, Apple TV, or Chromecast. And it has enabled them to bring efficiency through automation and analytics to really bring efficiencies in their DevOps tool chain because our solution is fully integrated into the CI/CD environment. So without further ado, let me hand over to Jonathan to give you more details on how our solution works.
All right, thank you so much, Gaurav. And yes, hello everyone. I'm gonna go through a few more slides here with some details about how our AV platform works, and then I'm gonna try and move into a bit of a live demo. Earlier this morning, there was an AWS outage, so we'll see how this goes. We may have to fall back to a video, but at any rate, the way that our AV platform works is a little bit non-traditional, I guess I could say, in that we try and get around some of the limitations that you run into with capturing streaming video and audio by kind of taking a hardware approach, I guess I would say. The way it works is that we have a device that we call the device under test. So this would be the screen and the speakers that are actually generating the video and audio that the user would be consuming. So this could be a mobile device, it could be a TV connected to an OTT device like a Roku or Apple TV, or it could be a smart TV itself. It could even be something without a screen, like a home automation speaker, something like that. But the idea is that we have this device under test, and then we have another device which captures all of the video and audio that streams from the device under test. And so you can see in this little schematic we have here, our device under test is shown as a mobile device. And then we have another mobile device which is set up to record the video stream and the audio stream from the first device. And it's doing this using a camera, not using a USB cable or something else. And this is to make sure that we're collecting the data that's actually being displayed on the screen of the device, as well as to get around some limitations that you can run into with collecting streaming video and audio from certain platforms. So this is a highly robust system in that all that's required is a camera and an audio collection interface. And then we put this sort of setup into a large enclosure that's sound and light isolated so that we can actually capture pretty high quality audio and video from the device under test. All right, next slide, please, Gaurav. So one of the other advantages of this kind of setup is that it lets us, capture streaming DRM protected content. So if you imagine a TV, for example, if you plugged in an HDMI cable directly to your Roku device or your Apple TV, you would not be able to digitally collect a streaming video and audio that's DRM protected. You actually need, by law, you need these special decoders, decoder chips that are placed in TVs that have been sold in the appropriate regions to decode DRM content. And so our AV box setup enables us to capture all of this DRM protected content because we're playing the content back on legally approved devices like official TVs that have the official chips and whatnot. and we're just capturing the information from the device in the same way that a person would. You know, we use our eyes and ears, and Headspin, we're using mobile devices, cameras, and you know, Bluetooth audio interfaces or whatever we have available in order to collect the streaming video content. So that's one advantage of our platform, is we don't have to you know, get into ethically gray areas of trying to break into DRM protected content. We just look at it from the outside, the way that people do. All right, is there another slide, Gaurav, or am I off to oh, I guess this is basically saying the same thing that I did before, just showing, instead of a mobile device under test, now it's showing a TV. So it's just a slightly larger sort of interface, but otherwise the idea is the same. Okay, next slide, please. So what we can do with this environment that we've created is basically to capture a lot of interesting data from either manual or automated test sessions that you run on the device under test. And along with all of the kind of normal analysis that Headspin provides, which I'm not going to go into detail about, the analysis that we provide for you know, mobile applications and whatnot, we have a couple of special kinds of analysis that we provide for specifically for streaming applications. So for example, the section that you see highlighted here in our little session timeline, it's labeled as Video Quality MOS, which stands for Mean Opinion Score. And it's basically our measure of a subjective definition of video quality. And so we have machine learning models that have been trained on, you know, hours and hours, you know, probably thousands or more of hours of video to determine what sort of video is good quality and what's bad quality. And we then apply this machine learning analysis to the session that you've recorded. So basically taking all of the data from the video and audio, and we can provide you a timeline of the video quality. So you can see here that the streaming quality of this video in this screenshot was generally in the okay range, but had a dip somewhere in the middle where the scrubber is at the moment. So you can easily go through this and try and look and say, is this some blockiness? Was there a network issue? What was the particular problem? So it helps you troubleshoot these sorts of issues. Is there another slide on this? Yes. So the other nice thing is that Headspin automatically sort of analyzes its own analysis as a way of speaking to call out issues that it thinks might be particularly egregious. So for example, by analyzing its own mean opinion score over time, the Headspin machine learning algorithms here have determined that there are sort of 3 counts of a poor video quality issue in this particular session. So you get a kind of nice list of issues on the left side that you can then drill into. And so ideally you wouldn't have any issues in that list, but if you do, you can say, okay, what happened in these 3 particular areas? Is this something that I should be concerned about? Is this normal? Maybe this was just the way the video looked, but probably it indicates an issue either with network that could be resolved or some other issue that you can then go and investigate in your development cycle. So that's the kind of idea behind what Headspin is trying to provide for, you know, media applications and companies. And before I go into the live demo, I'll just say that there are basically 2 primary ways of collecting this information. One is by using the devices manually. So we give you remote access to these devices, and you can use a remote control to, you know, walk through your user flow. Just switch over to show my screen here. And you can, actually, this is what I'm showing right now. You can use an included remote control to walk through your user flow, or you can actually write automated test scripts the way that you might be used to writing scripts for web or mobile applications. and then you can still collect the same data when running automated scripts. So both cases are useful, but obviously we care a lot about enabling CI/CD in all of this data collection. So you could easily write yourself a test script for your media applications, run it on Headspin, have the video analysis automatically performed, and have that feedback into your CI/CD cycle. So you could, set up alerts for yourself if the average mean opinion score of a particular video sequence drops below a threshold that you sent, and have that kind of be an alerting mechanism. So the possibilities are really, up to you to decide how you want to make use of this information. But I'll just go ahead and quickly demo both the manual and automated use cases here. All right, so I've got my screen up. This is an example of the user interface for what we call the AV box environment. And we have on the right-hand side, this is a Samsung TV. I believe it's an RU8000. So it comes with the Tizen TV operating system. And on the left is just a kind of what we call a control device that has a remote application installed. So if I want, I can interact with the TV directly using this remote. You can see I'm controlling the TV here using the same kind of interface that I would have on a physical remote. So this application basically just mirrors a physical remote. And if I wanted to start capturing video for this session, I could go over here and click Start Recording Session, and I would then get a record and an analysis of the session until I stopped it. Okay, so that is the manual use case. And now I'd like to talk about the automated use case. So, I'm the lead of an open source project called the Appium project that you may have heard of. Appium is very similar to Selenium, and then it provides a kind of automation interface and API for automating a variety of platforms. Initially, it was just mobile device platforms, and now it's extended to all kinds of platforms. And at Headspin, we really think that Appium is a great ecosystem, and we're committed to helping develop Appium drivers for all the platforms that we and our customers care about automating. So in the case of the Samsung Tizen TV platform, I've developed an Appium driver that lets me write Appium scripts that will then run automated test cases on a Tizen TV like this. So just to show you an example of a test case that I've written, I'm not going to go into detail on this code, but you can see I've got some Python code here and a bunch of helper methods. And then eventually I've got a test method that I've implemented that just uses the standard Appium and Selenium API to find elements or wait for elements and interact with them in a variety of ways. And I've got myself in a local instance of an Appium driver that I've used by connecting to the remote server that's connected with this Tizen TV. So assuming that the AWS issue is over, which it looks like it was, I'll go ahead and run this test script. Actually, first, I want to go ahead and start recording the session so you can see that we can run an automated session here. So this should be off on its way. And if this is all connected, we'll see now the TV start to operate in an autonomous fashion. So this test is just designed to automate a particular media app that I found. Oh, it looks like it may have had some state in it from a previous run. So hopefully that's gotten cleaned up. I was frantically trying to get this demo working again in the first part of the webinar while Gaurav was speaking, because there was a big AWS outage happening today, which was preventing me from connecting to our platform. So I was There we go. So things should be back in the correct state. So you can see we're just basically walking through the login flow and even, performing relatively complex operations like, walking through the use of this, virtual keyboard. We're not even using the remote to do this. We have more direct access to the underlying elements, which makes it easier. So that was basically a test of the login functionality and that we could get to the logged in user state. And I'll go ahead and stop recording the session. And at this point, I can look at a record of the session. I'm not going to look at a record of this session just yet because it takes a few minutes for the analysis of the session to complete. Instead, I'm going to show you an analysis of the same test that I ran yesterday. So you can see as I'm scrubbing through it, we've got basically the same session that was loaded. But you can see here we have the video quality MOS, and it's not surprising that the mean opinion score for this video is pretty bad. I should have said before, but the device that I'm working with is one of our development devices. All of the high quality enclosures are in use with customers at the moment. So I've just got this development device, and as you can see, it's set up in an office in an unclosed fashion. So you've got glare and reflections and things like that. So that's certainly gonna drop the video quality to a lower than average rate. But you can see that we have our issues that have been brought up here, including an issue called audio too quiet. I think that's because the audio isn't actually streaming from this particular TV for the sanity of those working in the office with it. Okay, so that's an example of how you can run an automated session on a Tizen TV device. This is kind of a smart TV case. I want to show you one other demo here. This other demo is with the Roku OTT platform. And again, this is just to kind of demonstrate that the Appium ecosystem is a good place for new platforms to be automated. We're constantly trying to support new platforms for automation, including platforms like Tizen and Roku, Apple TV works, all the Amazon and Google TV products work, and we're looking at things like LG and WebOS and basically any other common media platform out there to build Appium drivers for. So I'll just quickly show you. So here's some code for the Roku driver test that we're about to run. And it's basically the same. I didn't have a good Roku application to test on. One of the limitations of the Roku platform is you actually have to have the source code of the app that you want to test if you want to test it in a sort of robust way, which is fine if you're testing your own app. That's the usual case. If you don't have the source code or a development version of the app, you can still fully automate the device using the remote controls. You just won't be able to kind of introspect the element. So here's a test script where by and large, I'm just using the remote control interface to press buttons to open up different apps. And then once I actually activate my silly little dev app that I have, I can use typical Appium and Selenium functionality, like finding an element by XPath. I can print out the page source and then use that to figure out how I could find an element using the XPath locator strategy, and then perform the equivalent of clicking on that element, i.e. activating it with the remote. And I'll just say that this is a little bit remarkable because Roku doesn't itself provide any interface for doing this. So that's some of the intelligence that we've built into the Roku driver to give you a kind of nice Appium Selenium style interface for something that you would normally need to just kind of blindly use remote control commands to do. So let's go ahead and give this script a try as well. So here's our device owner test, and off it's going. Basically, the idea behind this test scenario was just to load up the Netflix app and try and watch its introductory video. I don't have any Netflix user logged in on this device, but this is just generating some moving video for us to look at to get a mean opinion score for. And we open up the Prime Video app for a handful of seconds, assuming that it loads, and go down to browse videos and just get some stuff displayed on the screen. And then from here, we'll open up the test application for which I actually have the source code. And at this point, we're finding, I think it's the top channels element and clicking on it. And then that's the expected result right now, because that's just a kind of basic test app. All right, so that test completed successfully. Of course, if I wanted, I could also use the Roku remote in a manual way, just like I showed with the Tizen device. And the result that we get in terms of the session analysis is just the same. You can see that because this device is actually set up in a real enclosure, the video quality is quite a bit better. So we have a much higher mean opinion score. And we've got pretty high page content scores. Right here, you can see in our page content analysis that it goes down to 0.1, which means very little page content. And this is exactly what we can see on the video. The screen is just black. And obviously, if you just have a blank screen for a long period of time, your users aren't going to be very happy. So if this were actually an application user flow that I was recording, I could use this information to say, what's going on here? Why is the screen blank for such a long period of time? Should we investigate a network issue? Should we maybe add some kind of animation or spinner to the page to give the user some kind of feedback instead of just showing a black screen? Or we might not be concerned because this is just such a short period of time. But anyway, that's the kind of analysis and insight that the Headspin AV Box platform gives you. And I think that's basically it for the type of demo that I was hoping to provide. I noticed that we've got, a fair bit of time left. So I'll go ahead and unshare my screen, and then we can move into questions. And if it's possible, happy to try and do any other demo during the Q&A period as well. So do we have Alec back?
Thank you very much indeed. Thanks, Jonathan and Gaurav. That's a great session. I can see some questions coming in. And actually, we had a question for the audience as well. Maybe you'd like to type in the questions and chat box. What we wanted to know is, how do you currently test your digital audio and video quality? So we'd be really interested to hear feedback from the audience on that question. I'll just repeat it. So it's, how do you currently test your digital audio and video quality? I'll start with the questions. I can see some coming in. I'm just reading them off the screen. The first question is, can you test VR or AR devices, 4K streaming video or other 5G ready content?
Yeah, that's a great question. I guess I'll say a little bit about it, and I'm sure Gaurav might have something additional to say. I mean, one of the nice things about VR and AR is that at the end of the day, they provide a video and audio stream that is collectible in some way. A VR headset, doesn't go into the kind of AV box model that I showed earlier, where you might have a phone trying to scrape the video from it using its camera. But usually we can get video and audio out from those types of devices. So all of the same sorts of analysis that I showed with the AV box environment is possible in the VR and AR space too. And we've done a few pilots with customers on this as well. So it's certainly something that we expect to grow.
Thank you. And next question that's come in, how would testing for voice activated devices work?
Well, Yeah, this is something that we have actually set up in our AV box environment as well. So if you can imagine, a physical enclosure with your voice activated device, your Amazon Echo or whatever they are. And then you have another device which is set up there to uh, send audio through the air with its speakers or capture audio through the air with its microphone. Then you have the same sort of basic model that I've already talked about. So you can remotely control the device, let's call it a mobile device, that's inside the enclosure with your Amazon Echo, and you can actually stream audio from remotely from your browser or from an API that will then be played back from the mobile device in the enclosure. So I could be at my web browser on the Headspin website and I could say, Alexa, do this thing. That audio would be recorded through my browser, sent to the mobile device in the enclosure, and played back so that the Amazon Echo device would actually hear that as if I were sitting in the room with it. And this is actually a little bit more difficult than it sounds, because these devices are usually engineered to ignore audio that they detect to be coming from other devices. So they try and distinguish between human voices and stuff that's coming from, for example, a mobile phone speaker. So we've had to do a lot of engineering to get the sound playback just right, and then capturing for the other part of the test, you want to hear what the audio device says back. So whatever Alexa might say in response would be recorded by the control device in the cabinet, and then that could be played back to me on my web browser through my headphones, so I can verify that I did the right thing, or it can be collected via the API.
Yeah, and just to add to what Jonathan said, I mean, the usage of voice is growing significantly for various reasons. I mean, we're all getting tired of typing, right? And then there are obviously safety concerns, like when you're walking or going up the escalators, and you're constantly texting, or say when you're driving. So to have this kind of solution, as Jonathan described, is going to be very, very relevant as the usage increases across different devices by different consumers.
Thank you. I had another question that's been asked. It's an interesting one, actually. Can a platform test DRM or other encrypted content?
Yeah, right. So I think actually I talked about this a little bit in the slide. And again, just the challenge of DRM is that unless you have a special chip in your playback device, you can't actually see the DRM protected content. So it's a special decoder chip, and I'm not sure of all the technical details on that, but it's very much a kind of legal fact about the world that becomes a technological fact in the form of these decoder chips. And so if you just have, let's say, an Apple TV sitting in front of you, and you think, oh great, I'll just stick an HDMI cable in and collect all of the video and audio from that Apple TV device digitally so that I can run an analysis on it. You can do that for the UI of the Apple device and for any content that's not DRM protected. But when it comes to DRM protected content, you'll just get nothing. So if you start, your favorite TV show, it'll just go blank. You won't be collecting any video or audio. And so again, our platform gets around this by actually, sending the output of the Apple TV device or Roku or whatever it is to a TV that we've bought from, an authorized retailer that has the appropriate legally sanctioned decoder chip in it, and then that TV will happily play back the content just like it would in your living room. And then we kind of from the outside capture that using camera and audio collection devices, usually a mobile device with a sufficiently powerful camera and microphone.
Thanks, Jonathan. I had actually a couple of people have asked the same question. I mean, I can answer this one. Will there be a recording available of this webinar? So the answer is yes. We'll make a link available to you shortly afterwards. We'll email everybody separately, so you'll be able to share this with your colleagues. So thanks for asking that. So I'll just see if there's any more questions coming, but I think that seems to be all the questions now. So I don't know, Jonathan and Gaurav, if you want to add anything extra to wrap up.
I mean, I guess for my part, I'll just say that everything that we've talked about here in terms of there's been certainly a focus on the media streaming aspect of things for this webinar, but there's a whole other side to Headspin, which is testing web and mobile applications, and that's sort of been our bread and butter. And so there's an awful lot of analysis that's very useful there in terms of performance analysis, and indeed all these same kinds of metrics that you can see, network analysis and all that, and it's all equally powered by Appium or manual usage or whatever other framework you want. So it's definitely worth checking that out, as the media portion is a really exciting and growing part of what we're doing, but by no means the only aspect of what Headspin provides.
Thank you very much.
Thanks for that, Jonathan. I mean, first of all, thank you to Unicom for organizing this event and for giving us the platform, and thanks to all the attendees who could make it today. Thanks also to those who registered but could not join for whatever reason. As Alex said, the recording will be available. You'll also have contact details of Jonathan and I. And so please feel free to reach out to us. We have a global team. We have presence in the US. Jonathan is based in North America. I'm based in London. We've got teams in Asia Pac, India, Australia. So we will make sure that we will respond to your queries, and would really love to set up follow-up conversations should you want to discuss more of your business needs and how our technology can be relevant for your needs. So huge thanks to everybody for taking the time today.
Thank you. Thanks so much. And Gaurav and Jonathan, a massive thank you for this webinar and taking the time to present it today. It's been really good. I think it's such a topical subject right now, and obviously it's borne out by the number of people attending and registering. So thank you. It's much appreciated. I hope everybody enjoyed it. Thank you for attending. Goodbye.
Thanks, Alec. Thank you, everybody.
Bye. Bye.
Yep.
Thank you. Bye.
Bye.
Bye.